Spring break packet, 56-point assessment. It's due Wednesday after break. Number one, all you have to do is FOIL, multiply these two binomials. Even though they have radicals, you just first, outer, inner, last. I suggest you write the FOIL vertically and then write all your work out. Number two, you're converting degrees to radians. I'm not going to give you too much help on this. Just realize that the conversion ratio is pi radians equals 180 degrees. Don't forget to set up your units so they cancel out. Number three, you have to realize the vocabulary. Domain is x values and range is your y values. So remember that domain is on the horizontal axis and your range is on the vertical axis. Number four, 2i squared plus 3i cubed is equivalent to which expression? You must memorize what I squared, I cubed, and I to the fourth are, and anything beyond that follows a pattern. You can also use your calculator to plug these in, and it will give you what it is equivalent to. So here's the explanation. I is simply the square root of -1. I squared is I times I, which is square root of -1 times square root of -1, which is just -1. I cubed is basically I times I. We know that I squared is -1, so that's going to be -1 times I, which is just -I. And finally, I to the fourth power is the same thing as I squared times I squared. -1 times -1 is +1. So if you just memorize this pattern right here, or you could just look at the I, say I1, positive, negative, negative, positive. Number five, you're looking for the angle that is coterminal with an angle that is -70 degrees. Remember, the coterminal means angles that have the same terminal side, and negative angles go in the clockwise direction, whereas positive angles go counterclockwise. Number six, they're asking for the principal value. You could either plug this in your calculator, inverse cosine, parentheses, -√3/2, close parentheses. Make sure you're in degree mode because all the answers are in degrees. Or you look at your unit circle to see the cosine of what angle gives you this result. Number seven, you could also just plug in your answer choices into the calculator. You can just go through, or you can just work it out on paper. Take your 1, plug it in here. 9 to the fourth power equals 27 to the third power. See if that gives you an identity. Or what you could do is you could do this algebraically, come up with a common base. You would want to recognize that 9 and 27 can both be expressed exponentially as 3 squared and 3 cubed, and then you bring down the exponent, distribute the 2, distribute the 3, cancel out the 3's, and then solve that way. Number 8, you're looking for the roots of this quadratic equation, therefore you must use the quadratic formula. Remember, this must be memorized. Set up your A, B, C. This is the coefficients are A, B, and C. And be very careful when you're simplifying your radicals towards the end. Number 9, which ratio represents cosecant of A in the diagram below? You must recognize all your trig functions. A trig function of an angle is the ratio of its sides, and you should have had this memorized. SOHCAHTOA, any which way you want to memorize this. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. And then you must realize that the inverse trig functions, the inverse for sine is cosecant, the inverse for cosine is secant, the inverse for tangent is cotangent. Number 10, you always want to start inside the parentheses when you are simplifying an expression. Then you want to rewrite any negative exponents with positive exponents, which means you'll have to reciprocate and then change to positive. And then the very last thing is the outer exponent which is the 1/2 power, which is really square root. Number 11, you really have three options. Method 1, you substitute, you solve the quadratic. Now you're lucky because both of these equations are already solved for y, so you just set 3x minus 6 equal to x squared minus x minus 6, and then solve algebraically. Method 2, you can just go through and plug in your answer choices. As you can see, this is solution set, so these are both x values. Okay, it's not an xy ordered pair, which means when you plug in 0 here and 0 here, you should get the same result. You plug in -4 here, you plug in -4 here, you should get the same result. Okay, that's method 2. Method 3, you graph both of these equations into your calculator, and the points of intersection are your solutions. Number 12, the roots of the equation 9x squared plus 3x minus 4 equals 0 are, you have all these options: imaginary, real, rational, equal, irrational, unequal. Probably the easiest thing to do, or rather the method that requires less memorization, is just to use the quadratic formula and look at the roots and see which one of these descriptions describes those roots. The shorter way to do it would be to only evaluate the discriminant, but this requires more memorization because you must remember if the discriminant is positive, negative, or 0, then which situation it describes. Number 13, I would rewrite this as a fraction first. It says that this is divided by this, so you want to write that as this first expression divided by this second expression. And the tricky thing is this negative exponent, which you want to rewrite as the reciprocal 1 over x minus 1, and then put all that over x minus 1. Now this will require you to come up with a common denominator, so you'll have to take care of this. So this really becomes a complex fraction where you have a fraction within a fraction, and then you'll have to find the common denominator. And I'm giving away too much, but you just multiply both of these by x, you get your common denominator, and then you do your keep, change, flip, and simplify, see which one of your options matches. Number 14, the general rule of thumb: when you see radicals in the denominator, you must rationalize the denominator. So you want to multiply this entire denominator by what is under the radical. Whatever you multiply in the denominator, you must multiply in the numerator. Now there's actually an easier way to do this. You could simplify a squared first, because that is a perfect square. If you take that and you take it out, then you have less to rationalize. Number 15, which graph represents a one-to-one function? This is really a two-part question. A function must pass the vertical line test, whereas one-to-one must pass the horizontal line test. Number 16, this is a transformation question. You must recognize that this transformation from f of x to f of x plus 5 is an outside the parentheses transformation, which means it is a vertical shift. You're actually sliding the function upwards 5 units, and that's going to change the minimum point of -1, -3. Number 17, the graph of y equals x cubed minus 4x squared plus x plus 6 is shown below. So we haven't spent too much time on cubic equations, but this is a cubic equation to the third power. As you can see, when you have x squared only, gives you a parabola, but here you have x cubed, so it gives you this shape. They want to know what is the product of the roots. The roots are the x-intercepts. So this is really an easy question. It's basically this value, and this value all multiplied together, because product means multiply. Number 18, you must remember that conjugate means all you do is you change the second term to the opposite sign. Number 19, there's two methods. First method is graph this in your graphing calculator. Y equals sine 3 pi x. The second method is to calculate the period. You have period equals 2 pi over b, which needs to be memorized. Now b is the coefficient of the variable, so it's 3 pi. So it's really 2 pi over 3 pi. And once you get your period, that is basically the amount of, or the interval of the x value for a complete sine function to occur, basically. So you'll have to just carefully look at all of your graph options. Number 20, you have two methods really. Method one, you want to see if the graphs are reflections about the line y equals x. So you could just plot all these on your graphing calculator and see if they look like reflections across the line y equals x. The second method is to algebraically try to solve these and match them. You just swap the x and the y and solve for y. So for example, number 2, we have y equals 3 plus 8x. Well, you swap the x's and y's. This is now x equals 3 plus 8y. And then you solve for y. You try to get y by itself. And you see whether it gives you this other function. If it does, then that is your inverse function. Number 21, factor completely. Whenever you hear factor completely, you have to check all 4 different methods of factoring. GCF extraction, trinomial, right, which is when you factor trinomial, you're basically unfoiling, difference of squares, and finally factoring by grouping, which really only works when you have 4 terms. So you know here we have a trinomial, it's not going to be that. Number 23, here's the graph of a circle. It gives you the center, it gives you a point on the circle. It wants to know what the equation is. Well, that means center radius form. You need to use the center point to come up with the center form, and then in order to find the radius, you need to use the distance formula or create a triangle on this graph and use the Pythagorean theorem to solve. So this is a perfect example of a time we need to memorize a couple of formulas. So here's the formula sheet I gave you to memorize over spring break. As you can see, here's the distance formula that you'll be using for this problem, and then also here's the center radius equation that you'll also need for this problem. Now remember, starting with number 21, these are all the open response without multiple choice, so these are worth 4 points each. Number 24, basically when you have a binomial squared, I would rewrite it as 2 binomials and FOIL it out. Just be very careful with your fractions as you multiply and combine like terms. You have to have a common denominator when you combine like terms. Number 25, solve algebraically for x. So here you have this big ugly equation. It has a lot of variables in the denominator. This is what you would call a rational equation. So you want to find the least common denominator to subtract the fractions first. So we have x plus 3 and 3 minus x. Now, if you recall, you need to extract a -1 in order to reverse the order of this expression. This is what we call the -1 method. So we take out a -1, and now we have x minus 3 in the order that we prefer, with the variable first. Now what's going to happen is that -1 is going to get absorbed into this negative fraction. As you can see, we have a negative and a negative, which makes it positive. The next thing you want to do is find a least common denominator in order to combine your fractions. Now over on the right side of the equation, I went ahead and factored the difference of squares to get x plus 3 times x minus 3, which really comes in handy. So I'm not going to give you any more help with this one, but I've set you up really well. Multiply throughout, combine like terms, and you can either cross multiply or you can just multiply both sides by the same expression to cancel out the denominator. Remember, the goal is to get rid of the variables in the denominator so that everything's in the numerator. There's no more denominators, no more fractions, and you can solve. The last step for any equation is to do your check step. Okay, you want to plug back in to see if you're dividing by 0, because this is a fractional equation. If you do divide by 0, you have to reject that solution. Number 26, there's really two methods for this. Method 1, this is the one that uses the calculator, where I taught you how to store values into variables, and then you just type in tangent a plus b, where a and b have the values stored from the inverse trig functions, and then that'll give you the answer. Now method 2, you have to go to your reference sheet, and whenever you see this tangent a plus b or sine a plus b, cosine a plus b, you must realize that this is the angle sum formula, so you have to go to your reference sheet. So here's your reference sheet, also known as your formula sheet. As you scroll down, here it is, functions of the sum of two angles, tangent a plus b. Now this gives you the formula that you can use to solve. Okay, so you have to find tangent of A plus tangent of B. If you go back to the problem, it gives you sine of A, tangent of A, but it gives you sine of B. So you have to draw a triangle in the first quadrant, and then use whatever method you need, like Pythagorean theorem, to find what tangent of B is, and then you plug everything back into this equation or this formula to solve. Number 27, the last question, solve algebraically for x. So here you have a logarithmic equation, and we want to go around the world to rewrite this logarithm exponentially, which is basically x plus 3 squared equals this fraction, x cubed plus x minus 2 all divided by x. From here, well, you need to FOIL and then get rid of the x in the denominator. And you can do that either by cross multiplying or multiplying both sides by x to eliminate the x over here. Then you just solve this, you gather everything on one side, set it equal to 0, solve quadratically, either by factoring or using the quadratic formula. So good luck to you with this. Also, don't forget to memorize all your formulas except for section 9 and 10. The formulas will be part of your exit slips for Thursday and Friday. So, these are the formulas that are given to you during the Regents. These are the formulas that you need to know, that you should know, you need to memorize. So these are the ones I gave you. And as you can see, it's, some of these are very simple. You've had these memorized for a couple of years. Circumference, 2 pi r. Arc length, we learned about this. This is the S equals theta r. They just wrote out the word radius. Area of a circle is pi r squared. You know that. Coordinate formulas. Distance formula, midpoint formula. Center radius equation of a circle. Vertex form of the equation of a parabola with vertex at hk. Here's your quadratic formula. You should have this memorized. Remember, we used the song for that. The sum of the roots, the product of the roots. Here's all your exponent laws. We have practiced this over and over. These are just your shortcuts, right? So if you have x to the third power times x to the second power, you're really just adding 3 plus 2 is 5, x to the fifth power. That's all that means. And quotient division is the opposite. You're just subtracting. Okay, the power law basically says you multiply powers, and the logarithm equivalence, you already know this, you go around the world. B to the y power equals x. All right, here's all your properties of logarithms, your product rule, quotient rule, power rule, and here's your change of base, which we also had studied this. When you have log base b of x, you can also solve this by changing it to log of x divided by log of b. Of course, when there's no base written, it's base 10. That means you can use your calculator. This is basically information all in quadrant 1 that you've already memorized on the unit circle. Here's your Pythagorean identities, which we had learned already. Here's your reciprocal identities and your quotient identities. Very easy. Transformations, these are all the rules. When you're inside the parentheses, it's a horizontal translation. When it's a vertical translation, you're outside the parentheses. When the whole thing is negative, it's a reflection over the x-axis. When it's only the x that's negative, it's a reflection over the y-axis. And then you have your vertical dilation by a factor of a. This is when you multiply the function by a certain coefficient. Section 9 and 10 we have not gotten to yet, so I don't expect you to have memorized these. We'll get to those later. And there you have it. Good luck to you, and I'll see you when you come back.